Hello everyone. Today we are going to solve Leetcode problem 977, which is squares of a sorted array. So in this, we are given a array with non-decreasing order, which is like an ascending order, which consists of both negative and positive number. And if we look for the constraints for the given problem, so they have specified that the length is less than equal to 10,000 and the elements within an array would range from negative 10,000 to positive 10,000. So, and numbers in this array would always be in non-decreasing order. So, if we take this example, so for this particular problem, I'm going to solve the problem with two approaches. One would be the brute force approach, where we'll square all the elements in that respective position. Like we'll square 4 with 16, 1 with 1, 1 square is 1, 0 square is 0, 3 square is 9, and 10 square is 100. And then we will use any sorting algorithm. Like I'm going to use arrays.sort in Java, which will be give sorting the array, and then it will sort the array in the ascending order, which is like this, and it will return to the calling function. And that's how we are going to solve the problem. This is the first approach through which I'm going to solve this problem. The second approach that I will be taking is the pointer approach. Let's discuss the second approach in a while. So for the first approach, so let's write first approach. For the first approach, the problem would be something like this. And it's simple. It's just we'll first loop through the entire array. Nums.length I plus plus nums of I equal to nums of I into nums of I, and then it's return. Then we'll do arrays dot sort nums. This is a void method which in behind the scenes in Java calls quick sort, whose with space complexity is log n. And like this particular will take a big O of n, and this one will be taking log n, big O of n. So the entire space complexity and time complexity would be n log n, and we'll return nums, and this is nothing but our problem, solution to the problem one. And if we submit this, this should pass and it should be accepted. So this is the first approach that I have been taken over here. So now if I talk about the second approach, the pointer approach that I'm talking about. So in the pointer approach, we'll keep two pointers, left and right. So for arrays, if we use a pointer approach, let me explain you the approach that I'm talking about. And um, since we every one of us knows that squaring a negative will always give us a positive number. So if we use math.absolute, so basically it will always take the positive side of an integer. So the approach that we have is we'll compare left and right element, like the start and the end of an array. Okay, we'll check which element is greater, and the greater the element, we'll place it at the end of the array. So so basically we'll define for three parameters and one array of n length. So there would be three parameters. Let's say left, right, position, and empty array, which will be like, let's call this as a sorted square array. So if we consider this example, it will consider a placeholder of 5 elements, which will be like 5 zeros. Okay, and this position pointer is nothing but uh, the place. So basically, the last sorted array that we have created will be a final array that we return, and which we will be filtering from right to left. So basically, our position pointer would be pointing to this particular location every time, and irrespect and let's for just for explaining purposes, let's put nums of left and nums of right. So here the position value, left value. So left value, since it is a starting, okay, let me also put, this is nothing but our left pointer, and this is nothing but our right pointer. So this is nothing but our right pointer. So right pointer is pointing at 10 and left pointer is pointing at 4. So the approach is, we'll compare 4 and 10. So if 4 greater than 10, which is false, so we know that 10 is at the right position. So we'll do the square, and with the help of the position pointer, we'll place it at the right position. Then we'll decrement the right pointer, decremented, move a step towards the right, then we'll compare 4 and 3. So 4 greater than 3, it's true. And every time when we decrement right or we decrement left, we always have to decrement the position pointer. So after we fill the last position, now we are coming and filling the second last position. So when we compare 4 and 3, so 4 is greater and 3 is smaller. So we'll do the square of 4 and fill this particular position. So in that way, uh, we have filled the position, and now now we'll not increment the right pointer, but we'll increment the left pointer. So our left pointer would point at 1, and our right pointer would still be at 3. So we'll keep traversing. Okay, let me explain you. So this will be 0, this will be 4, and this will be 4. So as per our explanation, so now nums of 0 and nums of 4, nums of nums of 0, which is 4 over here, minus 4, and absolute value is 10. And so we'll keep a condition of, every time we'll check minus 4 greater than 10. We are, remember that we are always doing a math dot absolute, so it will be 4 greater than 10 is false. So we'll basically fill, with the help of position pointer, we'll do a square of the right element and fill this particular position, and then we'll decrement the pointer and bring it to here, and the same way we'll decrement the right, bring it under 3, and decrement the right pointer. Okay, and then we'll check. So now our nums of right is updated to a value of 3. Now the second condition that we'll check would be 4 greater than 3. This is true. So now we'll increment left from 0 to 1, and as we said, we'll decrement, we'll fill the position 3 with the square of left, which is 4 square, which is 16. And then after filling the position, we'll decrement the position pointer and we'll point it to the second location. Now nums of 1 is nothing but minus 1. Okay. Now we'll compare absolute value of 1 greater than 3, which is again false. So which means that now we have to square the element at position 3, which is nums of 3 is 3 square is 9. We'll fill this particular position with 9. We'll decrement the pointer, we'll decrement this, the right pointer, and we'll also decrement the position pointer. we'll also decrement the position pointer, which was 3, but we'll decrement and bring it to 2. Okay, then now we have decrement the pointer and we'll bring it to 0 with the right position. So now your right will point to 0. Now the last check we'll have is 1 greater than 0. That's that's correct. So the condition check that we'll have is 1 greater than 0. This is correct. So now we'll do a square of 1, and with the help of sorry, I forgot to decrement the position pointer in the last iteration, so that's why my pointer was still pointing to 2. Now my pointer will point to 1. I'll update the pointer to 1 square, which will be 1, and I will increase this pointer from 1 position ahead. So basically, when both of my pointers collide at the same point, we come to know that our array is sorted. Like the array that we are looking is completed, and it's only one position which is not at the current exactly at the same position. So what we'll do is we'll decrement this particular position value. We'll bring the pointer here at this particular location. We'll square this 0 and we'll fill this particular position, and we get the answer array. So let's just code whatever we just talked about. So the second approach would be, so let's, as per the pseudocode, let's initialize three variables, which will be 0, right, which will be nums dot length. Let me just initialize a variable known as len, which will be nothing but nums dot length, and this will be nothing. The right pointer would be nothing but len minus 1, and the position would be nothing but equal to len minus 1. We'll also initialize an array which is sorted square array. Small, it's camel casing, and then we'll do a new int of len. By default, the square array would have a value of 0. All this will be filled by 0. So now, so our condition is while left is not equal to right. So this while loop will keep looping itself till left and right is not equal. If num map dot absolute of num, because we are checking with the absolute value, map dot absolute of nums of left greater than math dot absolute of nums of right. If this is the condition, will sorted square array of position. So we'll do nums of right into nums of right, and we'll do a right minus minus. So we are moving from right to left in this particular case. and else we'll just do this guy. This would be nothing but left plus plus. Okay, this is left and left. And we, as I said, we anytime we increment or decrement the left, we have to make sure that we keep incrementing, we keep decrementing the position. And here we return the nums array. Hey, not nums array. My bad. We return the sorted array. Let's try to see if we run the code. I messed up something. What did I mess up? If I sorry. So basically I had to interchange the if and else condition, because what I'm trying to do is if left is greater, then I should be incrementing the left. So rather let's do it like this, and else will decrement the right and keep coming to a left condition. And if we submit, we solve the same problem in, okay. So what is wrong over here? So, oh, sorry, I forgot to do this. So our first test case passed because our zeroth element was always like the first element was zero. I forgot to do that. So we are not setting the first position. Sorry, my bad. So the position value is not set. So what we have to do is we have to do the square array of position equal to nums of left. I forgot this one. Nums of right. Now if we run this particular test case, then we should be able to see it passed. Sorry, I forgot about this line. My bad. That's all for today. Thank you guys.